Hello, this is Renee Robinson, and in this video I'm going to show you guys how to do a simple grams to mole stoichiometry problem using the modern chemistry book you see in the top left hand corner. I'm going to do number 3A on page 287, and the question reads, acetylene gas is produced as a result of the following reaction. Calcium carbide reacts with 2 moles of water to produce acetylene gas and calcium hydroxide. If 32 grams of calcium carbide are consumed in this reaction, how many moles of water are needed? So in a grams to mole problem, you're going to be using the mole to mole ratio and the molecular weight. But in all stoichiometry problems, first things first, you always make sure that the equation or the chemical reaction is balanced. And in this case it is, and they have already balanced it for us. But with second thing you always do is you note what is given to you, and then you figure out what it is you are trying to find. And in this case, we're given 32 grams of calcium carbide, and we're trying to find moles of water. And in all stoichiometry problems, you always start off with what's given to you. So we're going to start off with 32.0 grams of CaC2. And we need to cancel our grams of CaC2, so we're going to put grams, calcium carbide here. And it's always 1 mole of that same chemical formula on top whenever we use grams. And this right here is our molecular weight. And here we have a calcium and a carbon, 2 carbons, 1 calcium. Multiply that by the molecular weights we see on the periodic table, 40.078 for calcium and about 12.011, which leaves us, again, 40.078 and 24.022. When we add that up, we should get 64.100 grams for every 1 mole of CaC2. And that comes right up here. So we're going to fill that in, 64.100 grams. And that cancels out our grams of CaC2. With moles of calcium carbide up there, we're going to put moles down here. And then we're going to put moles of what we're trying to find on the top. And again, this right here is our transition step that occurs in every single stoichiometry problem. Whenever we do moles over moles, we're going to pull the number that goes in front from the balanced chemical equation. 2 goes in front of hydrogen or water, and in this one there's a 1. Always a magic 1. Now that we have what we are trying to find in the top right hand corner, we can stop since we've canceled our moles of CaC2. And if we do that calculations, we would put in our calculator 32 divided by 64.10 times 2. And we should get some crazy long number that looks something like this, 0.9984399, etc. But if you look, in our question, there is only 3 significant digits. So we should transfer this number into 3 significant digits, so that would be about 0.998 moles of water. So basically a little less than a mole of water. And that is your answer. Thanks for watching.